Good day. In this video, we are going to learn these three objectives. First is draw the graph of a polar function. Second is find the area of the region bounded by the polar curve. And third is find the area of the region bounded by two polar curves. The first method to try for drawing a polar graph is to rewrite r is equals to f at 0 as the relation between x and y, and then draw of this relation. For example, when r is equals to 2 cosine theta, then we have r squared minus 2r cosine theta is equals to 0. But r squared is equals to x squared plus y squared, and 2r cosine theta is equals to 2x. So, x squared minus 2x plus y squared equals 0. Completing the square with x squared minus 2x is equals to x minus 1 squared minus 1 gives x minus 1 squared plus y squared equals 1. This is a circle of radius 1 centered at 1, 0. In other cases, the curve doesn't have a nice description in rectangular coordinates. That's usually why we're using polar coordinates. We then plot points as follows. Start with the graph of r is equals to f theta with r theta as the rectangular coordinates, and then plot the corresponding values of x, y using x is equals to r cosine theta and y is equals to r sine theta. In other words, we obtain a parametrization of our polar curve as theta is equal to t, r is equals to ft, and so x of t is equals to ft cosine t, y of t is equals to ft sine t. So draw the graph of a polar function. There are three methods. First is graph r versus theta. Then plot points as radar. Second, parameterize curve. X is equals to r theta cosine theta. Y is equals to r theta sine theta. Third is manipulate polar formula to get Cartesian equation. So let us now proceed in finding the area of the region bounded by the polar curve. The area of a region bounded by a single polar curve is given by the equation is equals to integral of AB 1/2 r theta squared d theta, where A and B are the values of theta that bound the area. Another way to say this is that the area of the polar curve sweeps out with a radius vector and rotates from angle A to angle B. So let's try using these definitions and formulas to find the area of a region bounded by a single polar curve. First, we'll look at an example where the curve is a simple circle, and then we'll look at a curve that is a dimpled limacon. Find the area of the closed region bounded by the circle. R is equals to 2 sine theta, and the lines theta is equals to 0 and theta is equals to pi over 3. Step 1 is note the polar equation for the curve and the bounding angles A and B. The polar equation for the curve is r is equals to 2 sine theta. The angles A and B that bound the area are A is equals to 0, B is equals to pi over 3. Plug in the polar equation for the curve and the bounding angles into the area formula. Then solve for the area of the region.